Good morning all. Welcome to the video lecture on unit number 3, different configurations of UAVs. In this lecture, we will be going with the different configurations of UAV. Just give me a second, I'll share my PPT. I hope my screen is visible to you. So without further delay, we'll move into the topic. So the different configurations of UAV, by now you are known with this term called what is an UAV. Basically it is an unmanned aerial vehicle. Now it has been changed to uncrewed aerial vehicle. So the different configurations of UAVs are here. So as of now we have gone with the 11 configurations which will be covered in this topic or the lecture. The fixed wing UAV, Bi-Copter, Tri-Copter, Quad-Copter, Hexa-Copter, Octa-Copter, Tilt-Rotor, tilt wing UAV. In the tilt rotor, in the tilt type of UAVs, we have two. One is the tilt rotor UAV, another one is the tilt wing UAV, another one is multi-rotor UAV, miniature UAV, and the last one is UCAV, and also we have another one which is your hybrid type of UAV. I'll be covering those things in the unit. Okay. So coming to the fixed wing UAV. So in this fixed wing UAV, the lift, which is the four forces, one of the major force is the lift. The four forces of your aircraft which are acting on your aircraft are your lift, weight, thrust and drag, in which the lift is the first parameter that we will be talking about. The lift which is generated using in type of this UAV is using the wings or the aerofoils. Okay, so not the primary force of generation of lift is not using the rotors. Okay, so the fixed wing UAV generates lift through wing surfaces but not the rotors. The forward thrust pushes the air over the wings, creating the pressure difference over the above and below the wings, where the lift is generated using those phenomena. Okay, so the key characterizations in terms of design would be your motion or the forward motion to maintain lift, can't hover, high cruise efficiency, suited to long range missions, launched using the runway, catapult or hand thrown. So this can be attained in the empty place where you call it as a ground. So there you can be doing it. Recovered via belly landing, parachute or using a net kind of thing. Okay, coming to the next case is your fixed wing UAV's performances profile. When you talk about the speed and endurance or the range and endurance and the speed and efficiency, the fuel power design achieves 12 to 24 hours of the flight. Electric variants reach up to 2 to 5 hours of the range and the endurance. Operating extends till the some extent to the kilometers. Coming to the speed and efficiency, the cruise speed will be around 60 to 150 kilometers per hour. Aerodynamic lift generated by means of the less energy which we spend due to the wing designs which is involved into it. Okay. So coming to a Bi-Copter, by the name itself it is telling the copter is converted into a bi, where you will be using two copters. Okay, so the Bi-Copters is generally, you can see here, there are two rotors which would be mounted with the propellers and all. These kind of arrangement is called as a Bi-Copter arrangement. So these Bi-Copters are basically difficult to stabilize them. The two rotors, one elegant control system can be utilized. So Bi-Copter uses exactly two motors, as I have already told, to control the lift and the stability. Rather than varying rotor speeds, servo tilts, manage the pitch and all. So these motors are mounted side by side or the one above the other. So the one above the other cases can be considered as the coaxial motor. So these can be the applications of this UAV is typically around the research platforms, cinematography, VTOL concept, and some of the compact surveillances where the huge amount of drones cannot be going. Okay. So coming to the design characteristics, they are mechanically complex, aerodynamic efficiency, compact in the form. Okay, so the servos, actuators all should be taken into care, must be, the example why we are talking about this Bi-Copters is a bit of complexity, because the four motors should be replaced by the two motors, and those two motors can be working based on these cases. Okay. So the efficiency in terms of aerodynamics can be minimized using the two motors. Downwards interfaces can be streamlined. Coming to the Tri-Copter, here we will be using three motors and the three propellers. So this arrangement is called as a Tri-Copter UAV. So two motors, one elegant control system. just a second. The 3 motors are the servo driven. Yaw is the solution where simply you are adding one motor and one propeller to a Bi-Copter. Okay, then that will be becoming as a Tri-Copter. Okay, Tri-Copter uses 3 motors in a Y direction or a T layout, because 3 motors should be fixed and cannot be fully cancel the rotation torque. So servo tilted tail rotor handles the yaw. Okay, so the 4 motions, the 4 forces you know, and along with the 4 forces we have the 3 motions, which is your pitch, roll and yaw. This pitch, roll and yaw will be controlled. In this, the yaw will be controlled using the third motor. Okay, so the configuration details would be 2 will be on the front and another one be at the back. So the rear motor is used to tilt, or the servo generates the yaw movement. Okay, so the arms are arranged at 120 degrees of intervals. In the Bi-Copter, they are exactly 180 degrees of degrees of the inclination or the intervals. The control and maneuverability of a Tri-Copter is based on your yaw authority, weight efficiency, and control complexity. Okay, so I'll be showing it to you the Quad-Copter, which is with me right now. So the Quad-Copter, by the name itself, it is suggesting the quad, where you have the 4 motors, 4 propellers, which would be mounted in the plus or the X direction. So when we are coming further, so the maximum amount of drones or the UAVs are based on this Quad-Copter arrangement only. So I'll be showing it to you. Just give me a second. I'll be showing it to you. So if you can see, I am holding a Quad-Copter where you have the 4 motors which are mounted on an X platform. So these 4 motors will be considered to be a quad. I am holding a Hexa-Copter, which is your Quad-Copter. So I'll go in, when we go ahead. Four motors symmetrically X or the plus pattern, as I already told. So this is widely used type of a UAV where it is more utilized for the stability, redundancy, mechanical simplicity. No servos are mostly required because we are not moving any kind of motors and all. So speed differentials between rotor pairs, we have the ESCs, electronically speed controlled devices, which will be altering the speeds of the rotors. 2 rotors moving the clockwise and another 2 will be moving anti-clockwise to counter the torque, or generally it is called as a torque cancellation technique. Okay, so throttle, when you want to go with the throttling and all the 4 motors will be increased or decreased accordingly. Pitch, roll and yaw, all this will be controlled using these 4 motors. If I want to move in the forward direction, I will be reducing the speed of the front motors and I will be increasing the speed of the back motor. So simply the drone gets tilted, or the UAV gets tilted towards the front direction and it starts moving in the forward direction. Whereas if I want to come back, I will be reducing the speed of the back 2 motors and then I will be trying to move them backward in the direction. Okay, so same ways, sideways, if I want to move left, I will reduce the 2 motors which are adjacently aligned. I will be reducing those speed and I will be increasing the right side motors. So vice versa for the right side also. So why quadcopters lead? These 3 reasons are the mechanical simplicity, flight controlled maturity, and the ecosystem, which is in terms of the controlled flight. Okay, the 4 motors, 4 ESCs, no servos will be required, and fewer be failed these cases. So coming to the flight controllers, we generally use with the Pixar flight controllers, beat stability flight controllers, Arduino, DJ, kind of flight controllers. Okay, so when you talk about the ecosystem, so they are almost available in all the kinds of your online shoppings and all, where you want to do the practices and all. You can try it with the small cases drones, which are available in your Amazon, Flipkart and so on. Coming to the Hexa-Copter, now this 4 rotors, additionally I am giving another 2, which will be the 6 motors, 6 propellers. So basically 6 rotors, which is used to lift up the major amount of the payload, power and redundancy. The Hexa-Copter consists of your 6 motors which are in the hexagonal pattern. Extra 2 motors will be given to this to increase the payload. Payload is nothing but the weight that will be carrying by your motor, which is crucially motor redundancy. So the configuration variants would be flat Hexa-Copter, 6 motors in the one horizontal plane, or Y6, which is your 3 arms with 3 coaxials. Hexa, which is your 6 cases where all the 6 motors will be fixed on the frame as the same case of your Quad-Copter. So the professional workhorse or the 3 defining strength would be payload capacity. So it would be, as the 2 motors have been included, the power is increased by now 2. 2 motors will be giving more amount of power when we give the 2 motors to the Quad-Copter, which will be increasing the range of increasing the payload or moving faster. So more motor redundancy, stability in the roller. So the 6 motors generate enough thrust for a range of 2 to 6 kgs of load. Heavy cinema cameras, multispectral sensors, and the agricultural spraying comes under this Hexa-Copter configuration. Coming to the Octa again, so the another 2 motors will be added to the Hexa, which will be now becoming a big huge drone where 8 motors will be mounted on the frame along with the 8 propellers. So as you increase the number of propellers or number of motors, the propellers and their sizes will be increasing based on their energy cases. So maximum lift, maximum redundancy you can be achieved. 8 motors placed on the Octa. At the top, multi-rotor performance built with the heavy payloads, which can be considered for the continue flying, land safely. After 2 simultaneous motors fails also, the other 6 will be working fine. So the common configurations would be flat Octa, 8 on the arms, 1 motor each. X8, the 4 motors with the coaxial dual motors, compact, fully redundant. Octa X or Octa Plus, which is your configurations where we will be talking about plus or the X configuration orientation. The heavy lift champion, generally we call it as the Octa-Copter, is the heavy lift champion. So 8 motors can be utilized to increase the payload from, in the previous case Hexa-Copter we discussed about 2 to 6 kgs. Now here it would be almost double, like 10 to 20 kgs of payload can be gained. So it supports all the cameras, heavy lidar, light detection, ranging radars, sensors, packages, simulation, etc. Okay, so dual failure redundancy, operational logistics, size, weight, energy demands, where the more amount of transportation, where you want to transform from one place to another place around 15 to 20 kgs. So these Octa-Copters can be utilized there. So now the very interesting topic is your tilt rotor, where the rotors till now whatever we have discussed are your fixed wing, the rotor is fixed or the wing is fixed. Now coming with the concept called the tilt rotor mechanism, where the rotors gets tilted in the operation, where the flying can be done, the lift off and in the forward direction can be achieved by the set of motors which will be fixed here. So as I show in the image here, so it is a fixed wing UAV where these motors can be used for the lifting off first and next moving with the forward direction. So the advantages would be VTOL, vertical takeoff and landing, fixed wing cruise efficiency, as I already told. So the rotors vertically hover and take off, lift is gradually increased, wing can be the main, again the main production of the lift is coming from the wing, whereas the motors directly give the sufficient amount of thrust to take off from the locations. So bridging between the two regimes, which is your rotor or the rotor operated drones with the fixed wing operated drones. So these are the, now these kind of cases are also called as your hybrid cases, where the wings will be fixed and the rotors are mounted on those wings, and the wings are generating the lift as well as the rotors are generating the thrust. So moving in the forward direction at some altitude can be achieved using this. So operational flexibility takes off from the ship's desk, confined clearance, the kilometers, or you don't require any kind of a runway. Cruise performance, fixed wing modes delivers 100 to 200 kilometers of hours per speed, where this can be extended till a bit of 250 plus also based on the type of motors that you give them. So the complexity only lies between the tilting mechanism, whereas the other things are fixed, only the tilting mechanism will be playing a vital role here. Coming to the tilted wing, as we have seen the tilted rotor, now this wing is the tilted one, where the wings can be now operated using a motor plus a wing. So this arrangement looks like this, where the wings can be blended and those will be like acting like a legs of your drone. Now once it has been taken off, then it will be cruising kind of thing using the wing cases. So in a tilt wing UAV, the entire wing assembly including the rotors tilted together, keeping the airflow optimal, aligned throughout the hover to cruise in the transition. Okay, so the tilt rotor, only two rotors rotate, wing stays fixed. Tilt wing, entire wing rotates, or the rotors rotate as a one unit, reduces the transition amount of drag. Applications would be urban air mobility, which is the now booming area in the research cases, where the urban air mobility is playing a vital role, where all the aircrafts will be replaced for a shorter range, will be replaced using this urban air mobility. Military cargo, maritime surveillance, long endurance. So these kind of aircraft generally they have an endurance about 12 to 18 hours of the range. So this tilt wing, we have the transition aerodynamics, hover challenges, eVTOL reliances. Coming to the next one, as we have already gone with the cases called Quad-Copter, Hexa-Copter, Octa-Copter. So if I try to want to go with the more amount of rotors and all, so they come under the category called Multi-Rotor UAVs. So when you talk about this Multi-Rotor UAVs, you will be adding more number of arms to your payload, where simply these will be fixed. So coming to the multi-rotor, so the multi-rotor is over changing category of all the rotary wing UAVs. More than a one rotor, Bi-Copters through the Octa-Copters belong here. So it comes under all these type of Bi-Copter, Tri-Copter, Quad-Copter, Hexa-Copter, all this comes under this multi-rotor UAVs. Okay, so here this will be giving you the capability, mechanical stability, versatility, all those can be integrated into it. So where you don't require any kind of a ground to go with the takeoff and cases, as it is a VTOL case, as I already told, vertical takeoff and landing cases can be implemented here. Omnidirectional maneuverability at low speeds you will be achieving. Electric batteries generally we use for the powering these cases. So short range endurance than the fixed wing in this case. So the capability system, your rotor count versus performance, how many amount of rotors you try to involve, and how many amount, what would be the amount of performance that will be taken care of. So you will be requiring more power, you will be adding the more motors and the more propellers to it. So flight control dependency would be around stabilization runs around 400 to 1000 Hz. Platform or the Hexa controller will be used, Arduino Pilot, Hexa, DJI, already we have discussed these cases. So generally the battery is powered for these kind of UAVs. So the typically lithium powered batteries will be used, generally we call it as a LiPo batteries. So which would be ranging around 20 minutes to 45 minutes of the flight. So again the technology for the battery swapping is a vital case here. So interestingly, the miniature UAV, which is a tiny part of a UAV, so this is around 150 mm in its span and ranging between 250 grams. Of the complete weight of your aircraft or the UAV will be around 250 grams. Okay, so the classes or the categorizations, this would be nano, micro. So nano comes under 10 centimeters, 10 grams. Micro comes under 100 to 150 mm, under the 250 gram. So the examples of this would be Black Comet PRS and DJI Mini 4 Pro. So this basically uses for the search operations or the rescue operations where the humans or any kind of a disaster happen. So we need to identify some of the cases where if someone is stuck behind these or there, so we cannot send the huge drones or the huge UAVs there. So there we will be using the small kind of a miniature UAV there. So this miniature UAV has a low Reynolds or the aerodynamics numbers. Power and endurance is also very less it required. System or the sensor integrations would play a very important role, where you will be talking about IMUs, GPUs. All this category drones will be coming based on the weight parameter, which is just a 250 grams. Okay. So now the another case where we will be talking about the unmanned combat aerial vehicle. Now, as of now, you all been aware of the war which is exactly going on between US, Iran, Israel, all those cases where the drones are playing a major role in types of defense technologies. Okay. So, autonomous air power. So this is UCAV is your unmanned combat aerial vehicle, where these are based on built just to go fight and come back, or else go destroy themselves and throw a bomb. This can be done. Okay, so it is precisely built to strike electronic warfare or the combat cases where this can be done. So the capabilities would be precision strike via laser guided or the GPS guided munitions, low obstacle stealth designs, reduce radar cross sections, human on the loop or semi-autonomous target engagement systems, emerging loyal wingman, air-to-air combat plays a very vital role in this case. The key parameters is here, as we have already discussed: endurance, persistence, stealth and survivability, autonomous systems. So now these kind of drones or the UAVs can be sustaining more than 27 hours of continuous flight. So the comparison between all the 11 types based on the metrics called as the endurance, payload, speed and complexity, fixed wing, rotor family, hybrid VTOL and unmanned combat aerial vehicles. So these are some of the comparisons where the fixed wing give long loiter time, moderate wing loading, high cruise velocity, simple and the proven design. When come to the rotor family, Quad is the best in the class of Quad, Octa, Bi, Tri and the multi-rotors. Quad leads the maximum lift. Tri is faster in the class when compared with the speed and all. Complexity, Bi and Tri-Copters take the very less amount of complexity which is involved. Coming to the VTOL cases, wing cruise efficiency is more, balanced trade-off, fixed wing cruise mode, dual regimes or the dual modes can be attacked. Coming to the UCAV, which is your unmanned combat aerial vehicle, long missions or the long range missions can be performed. Weapons plan and the sensors can be equipped as a payload. Jet class performance, because speed you achieve very fast in this kind of cases, and the complexity would be autonomous systems where you need to take care of all the parameters which would be included in this. So the applications of the UAVs, already you know in the unit number 2 we have covered with the agricultural or the different uses of UAVs in the agricultural sector, mapping or the applications. So the main case is your agricultural mapping, defense and security, infrastructure inspection, film and media, urban air mobility, and you name the type where you can generate based on your own advantages or the applications that you require. So the key takeaways would be the fixed wing type and the rotary type, hybrids, miniatures, UCAVs and the missions which you target to do. Thank you for your patience listening.